All right. I think it's ready to get started. Welcome to this talk. We're going to discover some really exciting features that have been added to C# over the past few years. C# is one of those programming languages that keeps evolving, and it's taking inspiration from other languages such as F#, Kotlin, Swift, Java, C, C++, and a lot of other good programming languages as well. So it's exciting to look at what's been added to the language because, quite frankly, the past 20 years has been quite some ride for a C# and .NET developer. So we're going to be talking about everything from C# 8 to 10. There's a talk on Friday that goes into details on all the C# 11 features that were just released. But if you haven't been working in C# for these past few versions, there's quite a lot that we need to discuss first. My name is Filip Ekberg. I'm happy to take questions afterwards. If you don't agree with any of the language features, it's not my fault, so don't throw anything in my face. But I'm happily here to discuss all language features, .NET, C#, and whatnot. And you can always ping me on Twitter or send me an email as well. So this here is a tag cloud that I usually show around what's been added in C#. These are a lot of the important language features. Some of them change how we architecturally have to think different when building our applications. When using async and await, for example, doing that prior to adding the task parallel library or even adding these keywords in the language was not a trivial task. Most of these things added to C#, except some things like generics, have always been able to, you've always been able to do that with C#, but with a little bit more code. So the idea with adding new language features is to avoid more keystrokes, make it easier for us to express ourselves in ways that were previously a little bit more difficult. So a lot of what we're going to discover here today is just compiler magic. The compiler is going to do a lot of heavy work for us. Some of the features we're going to discuss are as important as generics and async and await. And I have quite a few examples of how we can use this and how they will change the way that we look at our applications. Now, if you're like me and you love programming languages, there's a GitHub page. They open sourced the compilers some years ago. And you can participate in discussions around what's going to come in C#, some features that have been withdrawn from the language. And what's interesting in that is that Microsoft has recently invested a lot of time in some language features that got a lot of backlash from the community. So they listened and they removed that. And the rest of the community didn't like that. So no matter what they do, people are going to get upset. But GitHub is here so we can discuss around these language features. So you can always go in here if there's something that you want to learn about, because the comments here contain a lot of details on how you can incorporate this. A lot of the documentations from Microsoft usually have the normal, this is a dog and this is a cat, but I have no idea how to use this in my enterprise application. But the comments are filled with great additions to that. So with that out of the way, I just want to start off with some highlights from C# 7. Now, C# 7 was one of the first versions of C# where they did a point release. So they released C# 7.1, 7.2, 7.3, and that's the only time they've done that so far. I believe this was a proof of concept that they could release the compiler separately from the whole .NET ecosystem and from Visual Studio. Effectively, it's just a NuGet package. You could update that and get the latest compiler, and you get access to the latest features of C#. One of those features, or quite a lot of the features added to C# 7, set the base for what's going to come in C# 8, 9, and 10. But it's a long horizon, so they add a little bit of a language feature, a small portion that will eventually end up being something quite big. And pattern matching is one of those things they first introduced in C# 7. But as you'll notice later, pattern matching in C# 7 wasn't really ready for anyone to use because it required a lot more keystrokes than what the equivalent would have been in the past. But it still set the base for what's going to come next. Before we get to that, let's just talk about one feature that changed C#. Now, other programming languages have had tuples forever, but C# did not until C# 7. This here is how you'd use tuples in .NET and C# prior to C# 7. There's a type called tuple, and that's a generic type, and you use it like any other generic type. But then it's really difficult when you want to access the items on this thing. You have no idea what they are. So with some compiler magic and some really smart people at Microsoft, they added this as a first-class citizen in the language. It's a little bit different syntax, but this here creates the same thing. Behind the scenes, this uses that same generic type, and with some magic compiler annotations, we can get some information about the variable names and the field names here. Using this on its own allows you to return multiple return types from a method, or accept types that has multiple fields on them if you don't want to create a class for that or a struct, which is quite handy. But where it becomes even more powerful, again, is with pattern matching. You'll hear me say that quite a lot, that a lot of these features set the base for pattern matching. Something that came along with this, which is quite confusing, is this magic method. If you add this to a class, it will allow you to do certain things with that class or an instance of that class. The method is called deconstruct. It's not to be confused with a finalizer or a deconstructor, but it is a way for you to take an instance and pull different parts out of that instance. For example, in this case here, I did say that using persons and cats and dogs is a really great example. I should really follow my own advice. But then again, this here allows me to grab the first name and the age out of this person. It's a normal out parameter, which you might have used in very early versions of C#. But where this is different from what you've done in the past is that I can now take an instance and I can assign this thing here, this instance, to what looks like a tuple here on the left-hand side. This is also just compiler magic. It creates two local variables. It sets that into the out parameter, allows you to set the values into those fields. So while it looks like a tuple, it's not really the same thing. But they're very often confused together or used interchangeably. But this is nice. We can use this again with pattern matching, and I'll have a good example of that as well later on. But first, we need to understand everything else. So tuples or tuples, depending on where you're from or how you'd like to pronounce that, you say either tuples or tuples, but we really talk about the same thing. A tuple can be assigned like this here. This is a tuple assignment assigned to a local variable called coordinates. I can access those fields very nicely, very convenient. I could even return that as a named tuple from a method, which is also very convenient. Again, multiple return types is sometimes a good idea, but when you end up having 20 multiple return types, you should use a class. That's where we can use a class, right? So I can take this instance and I can assign that into two local variables, which looks like what we have on the top here, but the bottom one creates two local variables. The top one is a tuple. And this here is all done, or the last portion, is done by introducing this magic method. So the compiler will know that you have this available, and therefore the syntax also works. So far, we haven't really looked at anything that requires a change to the runtime, right? This here would be easily translated into C#1, 2, 3, 4, or 5, right? That's the fact with most of the language features that you can use in C#. It's not supported, but you can use newer language features no matter which .NET version you're using or .NET Framework version you're using. Some features, as you'll notice, require runtime changes as well. And Visual Studio or whatever compiler or environment you use will tell you that you need that in case you hit a wall. But since most of this is compiler magic and compiles down to the same IL that we've had in the past, many features work with older versions of .NET as well. With that being said, we've just covered some of the basic features in C#7 that we need to understand to go forward. Now, C#8, I just showed two features of C#7. So at this point, does it feel like C#8 and beyond can add much more to the language? Obviously, if it wasn't much more to add to the language, I wouldn't be here. So, of course, there's quite a lot to add to the language. But you'd imagine that the 8th iteration of the language couldn't add a lot of features. But take a look at this feature set here. We've got something called read-only members, default interface methods, or default interface implementations, depending on when you're reading their documentation. Pattern matching enhancements. Really, pattern matching enhancements is not really appropriate to call this because it's totally revamping how we use pattern matching. We're getting using declarations, static local functions, nullable reference types, asynchronous streams, asynchronous disposables, ranges and indices, null equalizing assignment, and there's a few more features as well. Now, if we look at other programming languages, I don't think I've seen many that introduce groundbreaking features so often as C# do, but C# do it because they look at other new programming languages that have these very important and smart features. They take inspiration from Kotlin, Swift, and Java, and other programming languages as well. And the same thing here, so C# can still be improved. And a few of these I've highlighted or bolded: the pattern matching enhancements, nullable reference types, and asynchronous streams. We're going to be taking a deeper look at that and understand this. But again, at the eighth iteration of C#, there's still quite a lot to learn. If we want to use this, now I said earlier that you can use the new language versions with whichever framework or .NET version that you want. That's partially true. Some of them do depend on runtime changes. So you have to be on VS 2019 or later to use C# 8 and .NET Core 3.0 or later. You should really be on .NET 6 if you're doing any new applications today. Or if you're looking at upgrading, it's easy for me to say that you should go with .NET 6, but upgrading to that might take a little bit of time. And especially, some of you, is anyone here doing WPF or WinForms on .NET Framework? There's quite a few. So you're probably wondering or thinking like, well, hey, all of this is useless because I can't do .NET Core. Well, you can actually do that now. You can use .NET or the new .NET thing. It's really confusing what you should call this new thing because it's a framework, but it's not .NET Framework. It's an incorporation of .NET Standard, .NET Core, and .NET Framework in one thing, and it's just called .NET. But we can use this to create WPF, WinForms, and other types of applications as well. Now, you'd probably imagine that it's just as a little flag that you change. It's not. That would have been too easy. So you have to actually create a new project that's targeting the new .NET version, move all your WinForms or WPF stuff over, but that will then give you all the performance improvements made in .NET. It will give you access to all the language features that do require runtime changes. But if you don't want to do that, you can always try and toggle a new language version as well. You can override the version of the language in the CS prod file to tell it to use C# 10 or 11, even if you're running on .NET Framework 2. You can try that and see what happens. What happens is that Visual Studio will tell you that, hey, you should probably not do this. This is a shared library that's shared between two different types of projects. I compiled this for an older version, and it's now telling me that the target that you're trying to build this for doesn't support this language feature. If I simply remove the usage of the language feature in this file, the error goes away. So the compiler is smart enough to be able to compile that using the latest compiler as well. This error here brings us into an interesting language feature called the default interface methods or default interface implementations. This is one of those features that really divide people into two different groups. Either you really hate it, or you just don't like it that very much. I'm kidding, there's probably a use case for this. I shouldn't be too hard on them. So this here is an interface. Now, we've all used interfaces, probably, and now this is an old one that doesn't have, it returns an object, and I'd really like to improve this to return a generic type instead. But if I do that, and let's say that this is a shared package or a shared interface in my entire company, if I deploy that to NuGet, people are going to get really upset if they have to upgrade their applications to implement my new method. There's ways around this. People have subclass, people have introduced abstract classes instead to try to work around this problem. But what Microsoft decided was a great idea is that why not allow method implementations in interfaces? That provides a default way of how this method is going to work. So now I'm not going to break anyone. What happens now is that no one has to implement this method here at the bottom. If I upgrade my NuGet package, or if I add this to an interface in my application, Visual Studio won't tell me that I have to implement this. It won't even tell me that I haven't implemented it and that it's available. So I have to go into the actual repository or have to know exactly what's in this interface to know that this needs to be implemented. which is a little bit annoying. But it's great for library developers, and that's one of the use cases that I see this being useful for. If you have a library that's used by a lot of people, and you want to break changes, but you don't want to upset people, you could always say, hey, throw new exception or whatever, and if they happen to use this, someone will find out, eventually. All right, so has anyone used this feature? No one, that's what I expected. All right, and you probably won't. But you will see that if someone else do this and you bring in a NuGet package or something from GitHub, don't get confused why Visual Studio isn't telling you that you're not implementing one of the methods that are available, because there might be a default implementation available. This is one of those features that require the runtime to understand the language change, because previously, the interface was a contract between the consumer and the class, right? So how would you run a method on something that's not available on what implemented the interface? All right, so the actual useful feature of C# 8 that I very much like is something called Nullable reference types, which again is a confusing name, but naming things is really hard. We've always had reference types that are nullable in C#. So why give it this particular name? What this feature is doing is that it's changing the way that reference types are looked at by the compiler. The compiler will now think that every reference type has to be set to an instance. You're not allowed to have nulls anywhere. So much like nullable value types, where you explicitly have to say, hey, I want an integer that's nullable by adding the question mark, you now have to add a question mark to indicate that you want a nullable reference type, which is very handy. Because we've all probably had this happen, right? Has anyone never seen this screen before? You are lying. I don't believe you. Or you're new, sorry. But we all eventually end up having this. So why not get the compiler to help us with this? Because there is one big problem, or there's multiple problems with nullability. First, it encourages that we add null checks all over our code base, even if it's not really necessary. That makes the code harder to read. Doesn't necessarily make it harder to understand, but more noise means that it's easier for us to misunderstand something. It's also ambiguous. What does it actually mean when a method returns null? Let's say that I'm trying to fetch a record from a repository. Personally, I always try catch everything and return null. But if there was a problem connecting to my database, should I get null, which is the same result that I might have gotten if there's no record in the database? I should probably handle those scenarios differently. So we don't know if it is actually unavailable, or if it's not found, or if it's an error. Instead, we could work with subtypes: user not found, user unavailable, or throw an exception when the database operation fails. A bigger problem is that it encourages mutability. That means that we can change objects. If something is set to null, someone expects this to be not null at one point or another, because otherwise, why would we even have the property or class to begin with? So why is that a problem? Well, nowadays, everyone's using Task and Task Parallel Library and doing mobile applications and doing async and await and all of that. Threading is a lot easier, but handling multi-threaded applications has not become easier. So it can become an issue when it comes to multi-threaded applications, because you will eventually end up having race conditions and trying to update things from different places where you shouldn't. So how can we get some help with this? We can ask the compiler to solve something for us, because I really don't want to end up having to write this all over the place. Someone in here is going to tell you, hey, that code doesn't look very nice. We can simplify that a little bit, but I still would prefer the compiler to tell me that this could potentially be a problem. If the compiler could determine that person, address, or street will never be null, this null check would be unnecessary. And in some cases, it can do that. We can help the compiler as well to indicate how we've handled certain fields and objects. And how do we do this? We enable this by either using a compiler directive, We can say that Nullable is now enabled for this method, for this class, for this namespace, for this file. We have a setting in our application or the CS_proj file that allows us to enable this for the entire project. And since .NET 6, this is enabled by default. That's the first thing that I enable in old projects as well. But we'll get to that soon. So what happens is that when we enable this, we can obviously see that string name is equal to null here is a problem because I'm explicitly saying that it's null. But the compiler is now telling me that, hey, there's an issue here, or it's just giving me a little bit of a warning. Imagine if this was all of a sudden giving me compiler errors. That would be a little bit annoying, and a feature that no one would turn on. So instead, it's just giving me a warning for now. Most of us look at our warnings tab all the time and fix all the warnings in our projects, right? You're lying again. All right, so to make it actually work with nulls, we'd have to say string question mark, and then all of these errors would go away. But we can see here that it's telling me that name may be null here, and it's in fact very much correct, because I'm setting it to null on the line before. It's much smarter than this. I have an example. We'll jump into Visual Studio in just a moment. But what I do, I'm a contractor, so I go to clients and I enable this, and I also set treat warnings as error to true. I check in my code and go home. And then all of a sudden, stuff breaks, and they call me back. No, I'm kidding. Let's have a look at how this actually works. But this is a great setting, and it is something that I encourage you to enable in a new project, because it will then encourage you to fix the problems, because no one reads the warnings. So I'm in Visual Studio. It doesn't matter which version. We can enable this for anything that's C#8 and newer. There's no warnings. Everything's green here. There's no issues found. I have opinions on my own code, but that's another talk. So now what I can do is that I can enable this by either using this compiler directive to say that this is enabled. And all of a sudden, I get two warnings here at the bottom. It's warning me about this particular class, that this class has two properties that are public. They are never set. So what I can do is to fix this, I should obviously set them to a value, and it would be appropriate for a constructor to set this value. If I just introduce an empty constructor, the warning goes to the constructor instead, because the compiler now deems that this should be set by the constructor. You have two fields or properties that are not set. So first, string last. Let's initialize this. Nope. First, right? And hopefully after this, if I can manage to type on this keyboard, last name. Oh, come on. Here we go. And the warning is now disappeared. So that's great, but now I broke the contract with everyone that's using this class, which is not very good. So I don't want to actually add this. I want to get rid of the constructor, because I want to know, honestly, the problem with null reference exceptions was never in this class. The problem is where someone uses this first name incorrectly, or uses this instance incorrectly. So to move the error to that place, we can add a question mark to say like, hey, the string here can be null. And this string here can also be null. And before I go anywhere else, I want to tell you about this keyword as well. This keyword is, instead of set, you can set it to init, which means that you can only set this once. You can only set it once you initialize the instance using an object initializer. After you've initialized the object, it's immutable. And with C#11, you can also say that this is required to be set. If I can spell required. There we go. You can say that you have to set this, otherwise there's going to be a compiler error. There's a lot more characters here than adding a constructor, but then again, this is a way to work around that we might have nullable types that are set by object initializers. It's a transition phase. 10 years from now, probably, or hopefully, no one will have to use the question marks all over the place. Now I fixed this class, but there's no warnings anymore in my application. I now have to go ahead and move this compiler directive to all other methods in my class. I don't want to do that. So instead, Let's get rid of that. And this can be done from the property page. It can be done from the csproj file. It's easier to find in the csproj file because I've already added it. So I'm setting Nullable enabled, and I'm also going to treat all warnings as errors inside this project. I'm going to save that and go back to my program, and hopefully, now we have a few errors instead. Now it's telling me that we have this details, which is an instance or a property that represents the details of a person. This is not a problem either. I don't want to add a constructor. This is going to be allowed to be null. Right, but I still have a few errors, and let's go ahead and fix them. This, we can just look at the code here. I'm getting an attendance. I'm calling this whoisHere method. And if we look inside this method call here, we have a place where this would blow up. One way to fix this is to use a very handy feature called argument null exception. And I want to throw an exception if this thing here, if details is null. Here we go. Notice how the warning disappeared when I performed a null check in the line above. There's something called null state static analysis. Try to say that 10 times fast. What that's doing is that it's trying to analyze exactly how your code is using an object or using that reference. It's trying to determine if it's been null checked or not. And the fact is that this method here has an attribute on its in parameter that says, if this method does not throw an exception, I promise that I've performed a null check. It doesn't have to perform the null check, so if the method is lying, you still have a problem. We can check this in multiple different ways. I could also say, well, if the person.details is not null, go ahead and do that. So it's very smart. It can even figure out the inverse of that as well. Right? We can invert that, and it would understand that as well. Super smart. And if I want to allow the person in the list to be null, I could say that this method here accepts a nullable, a list of people that could be null, and then I would get another warning again. So we can keep on adding this to places in the application, and we'll eventually find where null reference exceptions would be appearing. There's multiple different ways to handle this and solve this and work around this, as with anything. There's one more warning in the class here, and that's this method here is telling me that I'm doing something that I shouldn't. Here I'm saying that, well, this method is telling me that it returns an instance. I could say that I allow this to return null, but then again, I would have a problem somewhere else. Instead, I want to fix this. I want to promise that I've performed either a null check, and what's returned here is not null. Microsoft introduced the dammit operator to say that I promise that this is not null. This here is going to blow up. You're not smarter than the compiler. So very rarely do you have to use this. So instead, we can solve this by saying I want to return a new person, and I want to set this with a new details, where the first name is actually, I forgot yield. I have to do yield return, and I can set the first name to something. Why is it complaining? Oh, wow. Let's get rid of the required C#. I said that I shouldn't show any C#11 stuff, and I do that, and I break my own demo. Here we go. This here might be confusing. What is this thing? Well, we've all seen what we can do, for instance, new person, right? But why having to add these extra characters? That's a little bit unnecessary. The compiler can use this thing called the target type new expression, which is a new feature in C# as well. So what it can do is that it can figure out that you want to return a person. So why not just create an instance of that? It's not always going to work. Most of the time, it will. So with that being said, we've now fixed the problems of finding all the null reference exceptions in this application. And I do encourage people to go ahead and enable this in your applications and try and figure out where you get these exceptions. The first thing you'll notice is that you'll get them on your DTOs and your domain objects. But once you start adding the question marks and allowing things to be null, you might see it that pops up everywhere else. All right. Now, with that being said, I also do encourage people to turn on treat warnings as errors. Not just to be annoying, but because it actually helps. People will fix problems if it turns up, and if the build server blows up, people will eventually go ahead and fix that. So with C# 8, we also got what's known as asynchronous streams. This is another way of looking at data that's coming into an application. So let's say that I want to consume messages on a service bus. Previously, you had to do all your own custom connections to that, use some third-party libraries. It wasn't really all that trivial. With asynchronous streams, you could use a for each loop to very easily say, give me all the messages on this as they come in. Use a normal for each loop, you handle it like you normally do, and it's very easy to consume streams of data compared to previously. Let's jump into Visual Studio. Actually, let's do VS Code instead to spice it up. I'm going to go into VS Code, and this method here is going to produce a stream of data. You see the async keyword that I have here? Normally, you use that together with a task to return something that's running asynchronously. But in this case here, I'm using it with something that's task-like. I'm saying that this method here will produce an IEnumerable, where each element that I retrieve asynchronously will contain a string. If you've never seen async N08, this is very confusing. And I understand that, but hopefully it's easier to understand than what you had to do in the past. So then the first thing that I do here is that I open up a stream to a file that I have on my disk. I'm using another new language feature called using declaration. Look at, I have this using var stream, and then I just have the semicolon at the end. It's not wrapped in a using statement that like you normally see, because what happens with a using declaration is that it promises that it will clean up after itself when the method completes. And that's quite complex in an asynchronous context like this here. So then what we do is that we have a while loop that's going to read through all the files that I have in my file, read through each line. It's going to say, I want to get the next line available in this file. If this is a line, or if this is actually a string that I got returned, this is pattern matching. We're going to go into that soon. I'm going to capture that as a local variable called string, and then I can use this inside this while loop. Now, this is interesting because I previously had to declare this on the line above, use out parameters, and it wasn't very beautiful. This is much more nice. I have the await task.DLA to simulate a little bit of work. Let's say that we're grabbing something off a message bus, we're doing some processing of the data that we're loading. And then I'm using the yield keyword again to return this to the iterator. Or I'm telling whoever's iterating through this stream of data that there's something available. Looks complex, but this is the producing side of that stream, which is also important to understand. But often if you use, for instance, Azure, and I used Azure messaging as an example, their APIs will already do all of this part inside of them. So what you need to focus on is how we consume this. And that's very simple as well. So I have this await keyword in front of my for each loop. Normally, you see something like this here. For each line that I get of my chunk of data, I want to process each of that. This here would indicate that you're getting an IEnumerable as a result out of some asynchronous operation. If we put the await keyword in front of the for each loop, it means that I have an IEnumerable that will produce elements asynchronously from this method call here. And then we can use them inside this method or inside this for each body. What's interesting is that it goes ahead and calls that method, gets the first line. You then get returned into this portion here. You can process that. If you want to continue, it then goes ahead and loads the next one. Normally, when you load a chunk of data, it loads all of it, but this here loads one at a time, right? Let me just show you exactly how this works. This here is going to print my favorite song. If you don't know the song, or if you do, you can sing. You don't have to. All right. So that's pretty cool. Now, with a console application, that's very simple. With a text file, that's very simple. But it becomes quite powerful when you use this with things like a message bus or queues or anything like that. So the asynchronous streams are composed of two different parts. First, it's the way that we produce the stream of data. This here indicates that we are going to stream something. It's a string that will be streamed back to us. We're reading one line at a time. And then I'm using yield to return that, which is a very handy keyword that's very rarely used. It should really be used more often, instead of having to create your own temporary lists and so forth. In this case, there's no other option. You have to use yield. And then we are then telling the iterator that we want this, and we are opening the file. This is a little bit of a different way of saying or stating the same thing that I had earlier. Each item here is retrieved asynchronously. I'm setting that to my local variable, and I do some processing, and then I return that. So this is the producing side of that asynchronous enumerable. And then consuming this is very simple. I really like this, and this together with nullable reference types and together with the pattern matching enhancements that we're going to look at soon in C#8 were really awesome. But before we look at pattern matching, they've done some more changes in C#9 that I also want to bring into that sample as well, or that demonstration. C#9, again, introduced a whole lot of features that help us build more cleaner software, use less keystrokes, because someone else did it for us. We can do something called records, and we can use this very, very good type that was, I believe, one of the primary reasons that they started doing the rework on the compilers in the first place. When the compilers for the open source compilers, when they started doing that, one of the champions was primary constructors, which is really what record types eventually ended up being. So it took them 4 or so versions to get this into the language, which shows that this thing, or this language feature, is no easy task to solve. That was released together with the init-only setters that I demonstrated earlier, and the top-level statements that you might not have noticed, but the application that I had in both VS Code as well as in Visual Studio, none of them had this public static void main stuff, the method and the program class and all of that. That's all behind the scenes. It generates that for you. You can just go ahead and add C# code to the program.cs file, and you don't have to have all that boilerplate code anymore. This is very useful when you're doing something called minimal APIs, which is a very handy thing that's becoming more and more popular for nano services or microservices, or whatever you want to call them. Now, C#9 introduced a whole lot more patterns, which is why pattern matching is going to be the next thing that we're going to look at. It also introduced a target type new expression that I also demonstrated, and a whole lot more features that I personally haven't used and probably won't, because they're targeting more lower level stuff in C# if you do that. Native sized integers and function pointers and all of that. Very important things if you're working with, I don't know, Unity game programming. But personally, I'm very fond of the other ones here. So how about we take some time to talk about pattern matching, which is one of those important features that they've worked on from C#7 to 8 to 9 to 10 and 11. You'll see that with all the newer versions of C#, there's going to be more patterns added. And that's because they find new ways of being smarter about how to express ourselves. Pattern matching is all about being able to identify what something is. Does this puzzle piece have rounded corners? Is it transparent? What color is that thing? How many puzzle pieces are there in this set? Can you give me the middle part? Can you give me the first and last piece? There's so many things that we can express with pattern matching that, sure, we've been able to do it before with normal code or with LINQ, but being a first-class citizen in the language means that it's a little bit nicer. So I mentioned that we can use pattern matching in a whole variety of different ways. It's mostly about matching on what type of object we're looking at and what kind of attributes that object has, in terms of properties and values. Not the attributes that you smack on top of them using the square brackets, but attributes as in color, name, and so forth. In C# 1 through 6, you'd have to say something like this here. So like if the type of this thing is my type of what I'm looking for, and then I'd have to check a property if I'm looking for a specific color. Now this here is not really, there's nothing wrong with this. There's just a whole lot more characters to say something that I could probably express a little bit easier. Especially if you've done Kotlin or Swift, this here is like 50 more characters than you have to use. So in C# 7, they instead decided that why not require even more characters to express the same thing. That's why I said that in C# 7, pattern matching wasn't really ready for anyone to use. Because even though they said the fundamental pieces in the compiler to make this work, look at this part here. Case Apple, and then I capture this as a local variable of Apple that I can use inside this case block here, right? So I can use that as the concrete type. I don't have to typecast or anything like that, which is quite smart. But with C# 8 and with C# 9, there was a couple of improvements that made this a lot more useful. Instead of having to say, well, I want to create a switch for this thing, and then I have a lot of cases, why not translate that or inverse that expression and use it more like how I would express myself when talking to a customer. For example, I want a result based on this input. And inside this switch expression, which this thing is called, this is the object we want to create patterns for. So I want to produce a result, which is normally from a method call, something that you concatenate, something that you compute, right? So we want to get the result based on what kind of input we have. We fill this with expressions, much like expression-bodied members. The left-hand side is the pattern. In this case, a very simple type pattern, right, with the expression. And then I say this here produces a string. Doesn't have to be producing a string. The only criteria here is that all of them produce the same type, or at least the same base type. So this here produces a string, and the final one here, the underscore, that's a discard. It's saying that for everything that I haven't created a pattern for, that's what you're going to do here. Right? So that's when it's going to be returned from this pattern. This looks simple, and it really is. But C# introduces a whole lot of patterns to make this even more powerful. We just saw the type pattern on its own. That's very simple. I can say if this is an apple, if this is not null, if this is null, or whatever. But we can also use it together with the deconstruct method to say whatever you deconstructed this to, I want to match on the different values that you returned. We can use it together with properties to match values on properties that we have. We can match tuples or whatever your preference is. We can have relational patterns to say, hey, I want to find all the people that are 35 years older or younger, right? So you can write patterns for that. You can even build ranges to say, hey, I want to find everyone that's between these two age spans, or I want to find the ones that have had a birthday yesterday or today, right? And you can group these different patterns together with parenthesized patterns. You can negate them with a not pattern. All of these can be used together to create both very powerful expressions or powerful patterns. They can also produce very unreadable code, so you have to be very careful. But all of these, when used together, they produce something called a recursive pattern, right? And what that means is that it looks first on, for example, a type, and then we might want to look at a property. So it starts looking at the type, then it drills down and looks at more things on that. Before we jump back into Visual Studio, let's just quickly list the important language features in C# 10, because we're going to be looking at quite a few of these as well. We have record structs, global using directives. There's file scope namespace declarations. There's extended property patterns. So again, there's improvements to pattern matching. C# 10 was really mostly about improving what was already there. It's not introducing anything groundbreaking like all the patterns in C# 9. It's not introducing anything like asynchronous streams or the switch expression like C# 8 does. But it does introduce a couple of different language features that are interesting. So how about we jump into Visual Studio and spend a bit of time looking at C# 9 and C# 10. Let's start off by going to a different project. And I'll show you, I have this project here called pattern matching. It has a class called test result, or a file called test result. It's using this record thing. Record is a way to create a reference type. It's another word of saying that this is a class. It can actually be used together with the class keyword as well, but by default, a record is a class behind the scenes. You could also have a record struct, which was introduced in C#10. Depends on where you want this to be stored. But a big difference between a record class and a record struct is that record structs are not read-only. You'd have to manually say that this is a read-only record struct, and it becomes a little bit hard to understand and read. So let's go back to the normal record and talk about what this actually is. So this is a class. Why would I do this instead of just producing a class? If we expand this a little bit here, without looking at the body, just imagine that you can't see that part. This here is a primary constructor. It's defined together with what your class name is normally defined with. So I say that the test result is built up of a number of attempts and which date you tested this on. Then we can have fields and properties and methods and all of that inside my record. Why would I do this if I can just use a normal class? Using it for this sole purpose is not really its intended purpose. So I've created another record here. Actually, I took the same one. I pasted that into sharplab.io. It's the exact same struct or record that we just looked at. On the right-hand side, we can see all the decompiled code. So what we get out of this here is that we get a class that implements IEquatable. It has read-only backing fields. This here means that we have an init-only property. It's immutable. Records are immutable by default, which is what we want in a multi-threaded environment. It has the constructor. It also has a generated method to get a string representation of this, which is good for debugging, or if you're logging. So you can get this into logs. Very handy. And then if we go down here, we can see that it implements equality checks as well. Records come with value-based equality. So if you have two instances of a test result, it doesn't care if it's the same instance. If you compare two classes, it will only do a reference comparison. But with records, it will compare each member. It will compare the number of attempts with the test date. Right? That's a very big difference. But they also support adding methods, and they also support inheritance as well. I have a passed test and a failed test that inherits from that base class. Very handy. And here I've added a deconstruct method. Now, records do come with a default deconstruct method that takes all the properties that you define in your primary constructor and also creates a deconstruct method for that. But here I've created my own one because I want to do some computation. I'd like to be able to deconstruct a test result into saying, give me the test date and give me how many days ago that was. And I want to also indicate if it should be archived, for example. This could be whatever, just to give you an example. Now, to use it like that, to be able to then deconstruct this, I've created a new instance of a test result. I could then say, well, if my test result is able to be deconstructed into what I define in this pattern here. Now, notice here that this is where it does become a little bit confusing because there's no IntelliSense. I think I have to know exactly. It just tells me that there's no deconstruct that takes 0 arguments. So we have to know that the first one is test date. I don't care about the test date. Maybe I want to find tests that are 10 days older or older, and I don't care about the last one. This is extremely unreadable. No one will understand this. Like, if I go back to this code tomorrow, I will have no idea what I wrote. You can use named arguments as well, but since there's no help with IntelliSense, it does become a little bit difficult to understand. A better approach, actually before I show you the better approach, is that this here don't care if it's a test that's passed or failed. It doesn't care about the subclass. If I want to say that this can be a passed test, I have to specify that first. right? So now it has to be the exact type as well as being deconstructed into this thing. I could also say I want this to be passed, or I want this to be deconstructed into something like this here, right? So you can compose very, very confusing patterns, but it's also very powerful, as you'll soon see. So we can change this up a little bit here. Instead of having to use the deconstruct method, which is handy in some cases, especially if you match on all the different things that you get from your out method or your deconstruct method. Let's say that I instead want to say that I'd like to find where all the number of attempts, or maybe I don't have the days here, so I'd have to compute that myself. But this here is using a property pattern. It requires me to find a past test that also has this property set to a certain value. So we can use this with normal if statements, but we can also use this together with that switch expression. Let's say that I want to find the outcome. Based on my test result, I want to produce a switch. And in here, I have to produce or add my patterns. Now, the final pattern is the discard. That's the default thing. That catches everything. I could also say that I want to capture everything into a specific variable if I don't have that available, or x, for example. And now x here would be available as a test result or a nullable test result, because this may be null. It catches both the object as well as if it's null. And then we can add more patterns on top here. So why don't I add the discard at the top? Same reason you don't do that for normal switches. More granular on the top and the catch-all at the bottom. So we could say that I want to find all the past tests, or I want to find, I can't even spell, or we want to find, for example, failed tests, where the number of attempts is between, let's say, 10 and less than 20. I can then capture this as a, if I can just do failed test, right? So why would I capture this as a local variable? Because now I could either pass it into a method call, or I could use it inside here to produce a string. So this here will in fact be a failed test. It will be the actual instance that I can use in this case here, right? So this here shows the type pattern. It shows the conjunctive and patterns. I show the or pattern at the top. You can also have, the parentheses here, and that would create one of these parenthesized patterns just to group it a little bit more nicely. These are very powerful. And you could, of course, also, as I mentioned earlier, you can use a not pattern to negate an entire pattern. That means that you cannot capture it because it has no clue what you're looking for. Even though the pattern works, without a test case for this, I have no idea what this code will actually find. It will find all past tests that are not between 10 and 20, right? It becomes a little bit confusing, so be careful when you add this to your projects. The not pattern is great in one particular case. If test result is not null. That is perfect. That's a perfect opportunity to use that. All right, so that showed the record types and the fact that they do have value-based equality. So now if I created two instances, test result 1 and 2, and we were to compare these two, we know that test result, let's do var result is equal to, if that is equal to test result 2. This would in fact go ahead and compare each property with each other. Now you would probably imagine that these would be equal, but since I use datetime offset.now, it includes the ticks, so they will not be equal. Very confusing. But just a little bit of a hint that I have a course on dates and times on Pluralsight. All right, joking aside, C#10 then introduced quite a whole bunch of features as well. Not as important as the ones we've looked at in C#8 and 9. Record structs is good if you want to store the struct on the heap instead of the stack. And the global using directives, actually I didn't show you that, the file scope namespaces. Default nowadays is that Notice that I don't have to add any usings at the top, except for my own namespaces here. I don't have to do using system.link or anything like that. It's because, if you go into the project file, it has this thing called implicit usings enabled, so it will bring in all of that for you. It will just implicitly include things that it thinks that you need. And instead of having to wrap my entire file inside a namespace declaration, we can say namespace at the top, and this entire file now falls into that namespace. Which is also default when you create a new class in some cases, and in some cases it's not. Visual Studio tends to not be very, not do it similar for all cases. But it's nice, that's one of the things I go ahead and change as well. Just get rid of that indentation. Makes it easier when you code review. So C# 10, as I mentioned, introduced quite a few things as well, but not as groundbreaking as what we saw in C# 8 and 9. It did add something called constant interpolated strings, which is what some people have been asking for as well. So if you have a constant string, previously you couldn't use that when you did string interpolation. One thing that was really good, though, is that in previous versions of C#, this here is C# 9, you had to explicitly define which delegate that you wanted if you did a lambda like this here. Why would you have to do that when the compiler can just figure it out for you? So in C# 10, it can infer that for you. So if it understands what you're trying to do, it can infer the lambda. So you don't have to explicitly say the type here. Now, I did mention earlier this thing called both top-level statements as well as minimal APIs. This here is an example of a minimal API. I have an app.mapget, so I can map a specific path on a website to this thing here. There's just like 2 or 3 more lines above this to create an actual web application. And this is just a program.cs. Now, in C# 10, they added the portion here from header, so you can have attributes in lambdas. Previously, you couldn't do attributes in lambdas, which made minimal APIs like this here sometimes hard to work with, because a lot of things in ASP.NET requires attributes. So with about 2 minutes left, let's go through C# 11. Now, there's quite a few things in C# 11, and I did mention that there's a talk tomorrow by David from Microsoft who's going to jump deep into C# 11. There's a few features added to C# 11 that's great, and some were removed due to community backlash. But to give you a little bit of a hint, there's more patterns. For example, you can now look at a list to say, I want to get the first part or last part. You can slice off a little bit of a portion. There's some changes to name off. It's finally caching delegates for static method groups. It's a little bit of a performance improvement. The required properties, I showed you that. It allows you to then say that a property is required when you create an instance of that. We can have raw string literals, which if you've ever done VB and you've done XML code inside VB, it's pretty much the same thing. It's amazing. I don't understand why it took so long. Together with that, static members in interfaces, UTF-8 string literals. So you can say that, hey, I have this string here. It should actually end with U8, and that would be a UTF-8 string. And you would assign that to a span of byte. Why would you want to do that? Because all communication over the wire is mostly done in UTF-8. So that would require less computation, converting back and forth. Very good for performance. And generic attributes. This is one of the features that I've been wondering why they haven't added for a very long time as well. The one feature that I did say that they removed due to community backlash is the null checking, or the parameter null checking. If you added the double bangs on an input parameter on a method, it would automatically do a null check and throw an exception if it was null. Which your code ended up having question marks all over the place because you had null reference exceptions or nullable reference types. And then you had exclamation marks everywhere. It just got really hard to read the code. So with that being said, there's quite a lot happening in C#, and I have a few courses on Pluralsight on new things in C# 10, C# 11, 12 coming next year or later this year. So there's quite a lot of things to learn about the language. I hope you enjoyed this and learned a little bit about C# and that you're excited to try some of these new features. And as I mentioned earlier, if you have any questions, I'm here for the rest of the conference. I'm available on Twitter. And don't forget to vote on your way out. And thank you so much for coming and listening to me.